Hello everybody and welcome to Office Hours. This is I always have to check the date. This is the November 8th edition. We're doing these about once a month as given that I don't get to travel as much as I would like. And even if I was able to travel, I'm not sure inviting 20 people to meet at a bar in a faraway location is the right thing to do until the whole COVID thing is even more under control, although let's be optimistic and hope that it is going to get better soon and we can get back to normal. But until we get back to normal, I'm going to do these once a month. We just started this and I didn't know exactly what the reason for it was. I just know that if I get together with you all and good topics come up, and we have 2 hours, so we're not in any rush. And what's started to happen for me as we've done this a number of times is that I have all these like stories to tell. And I want to talk to you and I want to hear from you. And we have good questions every time. And you can even challenge me. And in the chat, challenge me if you, oh, we got no sound. We just got a note that there is no sound. But let's keep on going. I don't know. I assume it's going to get fixed. Please in the chat tell us if you get sound, because we need to. Let us know. Let me know if the sound is working. Boom. Okay. Oh, there is sound. Okay. Was there sound all along? Great. Thank you. Thank you for helping us with the sound. So, unless you have really good questions, which I'm going to keep an eye on the chat, and unless you have really good questions, I'm going to just tell stories, and that's fun. And one of the things that during the past almost 2 years now, where I really didn't get on airplanes and didn't go places, the one thing that I used to do a lot is go and give talks, and I would give talks about my research, and I would give talks about like how I built Python for everybody, and I wanted to show how it's open source and like everyone could do what I do, and I give that talk over and over and over and over again, and everyone goes like, oh, that's really cool, but then no one really takes action, and so I find myself flying all over the world, giving the same talk over and over, and just feeling like people come and they're entertained by the talk, but then there's no action that comes out of the talk. And so what I'm thinking about doing, and I'm getting less and less busy. Last month was really crazy. November's going to be better. I want to start giving keynotes to like online technology conferences, but do them online. And then when I get back, I want to start doing more keynote-y things where I talk about my thoughts. As you can tell, I'm getting old, right? I probably will be retiring in 10 plus years. And I really want to share some of my 40 years of experience in programming and computing in a way that maybe I can give to the next generation of people who are teaching, learning, and working professionally in the programming space. And I'm working on, we've done some stuff with Quora based on your questions. I've written some Quora answers, and those answers were picked up by Forbes Online, and I realized, wow, I could have a voice. I could not just publish sort of graphs of standard deviation and stuff, but actually my vision, my ideas, and what I'm thinking of. And so I'm going to be working over the next few months. I've got a meeting in a couple days with a mentor of mine to talk about how to write for magazines. Not how to write for journals, but how to write for magazines or New York Times or something like that. And realizing that at some level, if you're doing research, writing in a journal is important because there is kind of this evolving knowledge, and the journal is the record of each sort of step in the evolving knowledge. But a magazine is the way you touch touch and influence a broader number of people, and so I want to want to start to change the world. I mean, I've done this from the beginning to change the world. I was attracted to programming in the first place because it seemed like I had an audience. And before I came into programming, I thought I was going to be an actor. And I wanted to be an actor. I wanted to be Mr. Wizard. I wanted to be on television. Whoa, I'm on television now. Isn't that great? I wanted to have that stuff. I'd like to be an expert on news programs about education and technology and the internet. And so I'm just going to start doing that. And I'm going to do it here, but you can stop me. And yeah, the Quora thing, I tried to use that, and it just doesn't work as well as I'd thought. Yeah. So, hey, I got a question. I got a question from Fatima. I have a question, Dr. Chuck. I'm a student of computer engineering in the second year. After my university, what should I do to really call myself an engineer? Well, Fatima, is this the first time that you are listening? Because you know that that is a topic that I love to talk far too long about. I'll talk just briefly about that and then get to the story that I wanted to tell today, which is completely related to your question. And here's the problem that I've been struggling with, and I've mentioned this on previous office hours. The problem I'm struggling with is I, as the leader of an open source project, I want to hire people. And we've talked a lot about how to get your first job, et cetera, et cetera, et cetera. And so I would love to hire people, and I would love to find a way to hire people around the world, not just in my town, but hire people all around the world. And so then I asked myself, well, what kind of skills do I need to make it worthwhile to hire somebody? And I have come to realize, just both a long time ago and a short time ago and most recently, that if you have a computer science degree, I'm not ready to hire you. And the reason I'm not ready to hire you is that there are companies that are going to hire you for way more than you're worth. And that's the charm of a computer science degree, is that you're not all that talented in terms of what companies need to get done, but you are really skilled and extremely trainable. And so there are companies that will pay you six figures if you graduate from a great school, pay you $100,000 or more if you graduate from a great school with a computer science degree. But I'll be honest, I almost have never met a person who graduated with a computer science degree that's actually a useful and productive contributor to what companies need done. You go to work for Facebook, they'll pay you six figures. They will pay you six figures for 2 years. And then all of a sudden, after 2 years, you can actually help them solve the problem. And I can't afford, in my little company, in my open source efforts, I can't afford to pay a person $100,000 for 2 years before they're useful to me, before I get work out of them, before they advance the cause that I want to spend the money on. And so the way computer science works is it produces these graduates that are ready for 2 more years of training, but graduates who expect to be paid $100,000 a year for those 2 years of training. And there seems to be an almost unlimited supply of jobs for people that do that. And so that puts me in a bad spot. The other thing that puts me in a bad spot is I've got a lot of online courses, and you can take my courses, and they're increasingly sophisticated. Python for everybody, Django for everybody, web applications for everybody, and Postgres for everybody. These are the skills, the base skills that I want in a person that I would hire, right? Database, web, HTML, request response, JavaScript, Python, data science. It's all in there. It's all in those 4 courses. But guess what? I can't hire a person who aced all 4 of my courses either, because they have much to learn still. And so and this goes back to your question, Fatima. The question is, what is it that you learn after you've learned the basic skills, whether it's taking my courses or getting a computer science degree? And what you learn is how to deal with complexity. and how to deal with software that lives a long time. If you look at every course and every assignment that I've ever taught in any course that I've taught, and if you look at every computer science class, you see that you sprint for 2 weeks and then throw it away. And then you sprint for 2 weeks or 1 week and throw it away. Even my classes, they're even shorter. In 1 week, I'll give you 2 or 3 assignments, and they're all small. And the reason they're small is that if I started out and gave you a large project in Python for Everybody, you're in the first week, and I'm going to say you're going to work on code for 5 weeks, and you're going to work on code that's 100,000 lines of code, and you're going to fix a 1-line bug in 100,000 lines of code, and you don't even know what an if statement is. Well, you're going to quit. You're going to leave my class, and I can't have that, right? I got to teach you what an if statement is. So until you have the basic skills, I have to teach you the basic skills. But at some point, we have to flip and change what it is that we teach and learn from basic skills to applied skills, to applicable skills, to the skills that you need. And so I'm working on that. And the skill that I want to teach you is I want to teach you the long view of it. And Fatima, I'm going to get to your question. I would, if I were a second year person, I would, as a kind of a hobby, might get involved in an open source project, get involved in a large open source project, do anything. Because the thing that you're not going to get from your degree, whether I'm teaching or someone else is teaching, is how to deal with older code. Because all we ever do is we show you how to start fresh and throw it, and then work for 2 weeks and then throw it away. And so for me, I would try to find opportunities as early as possible in your education to engage in things that are not pretty, things that are not simple, things that are not brand new. Because what we do in technology is we often work with large, less than ideal legacy code bases. And that's what professional people, that's what people desire. And that's when I'm hiring someone, I want someone to work on large, complex code bases and solve really tough puzzles in those code bases, whether it's building small new features or fixing bugs in those code bases. That, to me, is the most valuable skill, and it's difficult. And I'm working on it. I'm trying to come up with a curriculum that leads to what I call top-level professional programming competence. And I don't believe literally that there's any program in the world, not taught by me, not taught by anybody else in the world, that actually graduates professionals. And before you start jumping up and down and talking about boot camps do not do this. Boot camps fill your head with knowledge so that you can do really well in an interview, and then you get the job, and then you kind of suffer for a while, and then after a while they'll pay you a bunch of money because they couldn't get anybody else who knew Ruby on Rails. You pass the interview, they're going to pay you money, so you tend to get jobs after boot camps. But that doesn't mean that you're a top shelf contributor after boot camps. If they can afford you long enough and you stick with it long enough, in a year or two after a boot camp, if you're paid, then you might become a contributor. And so that's the key, is to how to get people to be a contributor. So Fatima, it's really about, oh, you're not a programmer, you're just an engineer. Oh, well, I'm sorry. I answered your question as if you were a computer science engineer. So I'm not an expert on how to be a mechanical engineer or electrical engineer. I do know that my father was an electrical engineer, my brother was a mechanical engineer. So I know people, but it's just hard. And I would say that the thing that's true in mechanical engineering, electrical engineering, and all forms of engineering is, I'm sure it's about the same as computer science, in that when you graduate, you're not like job ready. You are ready to learn on the job. So, okay. So Sina, the question you ask is, I've got a question, Dr. Chuck. Do you have any suggestions for a mechanical engineer to try to use Python in the career? Useful integrated development environments, libraries, career paths, etc. Well, Sina, I would say that the first thing that you need to do And I get a similar question to students who want to take my on-campus Django class, and they go like, how much do I need to know to take your Django class? And what I tell them is, you don't need to know, it's not like you need to know a large amount. What you need to know is be secure in what you know. And if you were to take my Django class, you just can't study for it. But it is based on Python. And by the second week, we're going to just be writing Python and doing all this Python stuff. And so what I would say, if you want to understand Python, is don't try to worry too much about advanced Python. Get to the point where basic Python, like that Python that's covered in Python for Everybody, that scope of knowledge, get to the point where that's really locked in your brain by taking multiple beginning Python courses. Because if you're going to apply Python in an engineering career, you really don't know what's going to come at you, right? You're going to be an engineer, and there's going to be a little side problem of, we need to do some visualization. Oops, we got to do some JavaScript and some Python and some database. Or we need to do a simulation, which is, it's going to use a spreadsheet and some Python and da-da-da. And so there's no thing that says I can predict what it is that you're going to encounter in your mechanical engineering career. What I can predict is Python will be there, and you're going to have to learn when you get there. And if you're learning Python, then you're behind. And so for me, you got to get to the point where the concepts of programming are completely native. Understand object orientation. This is actually I'm just learning that, as I'm teaching, I'm learning from my own teaching and talking to students that the hardest concept to teach is object orientation. My Django class really, even though it's a web design class, a web development class, it is about object orientation, because the whole Django architecture uses object orientation to accomplish big and complex things with real simple bits of code. And if you don't understand object orientation, you can't understand Django. And so you kind of have to understand simple procedural programming, like ifs and fors, and simple data structures like lists and dictionaries. And then you have to understand object-oriented programming. And object-oriented programming is hard to understand. The basics of object-oriented programming are like a 30-minute lecture, but that's not understanding how object-oriented programming works, to solve problems, to make difficult problems easier. And so this notion of, well, you do a def and there's a self thing and self.this, and that's an attribute variable, and then there's a method and all that stuff. The terminology and the syntax of object orientation is not understanding object orientation. And literally, every time I have a chance in any course, and in my Django course, I teach object-oriented programming twice. I teach it once in Python, and I teach it once in JavaScript. And literally, in the last 2/3 of that class, everything you do in Django is extending some object or adding a mix into an object or something like that. And so I really like the Django class as a way to learn object-oriented programming. And so this is another problem where traditional courses think of object-oriented programming as learning syntax, not learning object-oriented programming as a way to solve hard problems. They give you assignments that solve easy problems, which in some ways are almost a distraction from the actual way you use them. You take a class, take a class called Advanced Object-Oriented Programming, and they'll just teach you more syntax, and they'll give you harder assignments. But it's usually coming from teachers who have never built an object or used an object in a production environment in their whole lives. And so they think of it as syntax. I mean, I know I taught EECS 280 here at University of Michigan in 2001, and I had not written a lot of large-scale code back then. And I taught it like syntax. I taught it like everybody else does. So, okay. So Chuck, can you suggest some courses to data science? I've done your Python course. What should I do next? So it depends. I like taking the Django course next because it really reinforces your Python skills. But if you feel good, Abdullah, if you feel good about your skill in Python, then I recommend taking, assume you're on Coursera, taking what we call ADSWAPy, the Applied Data Science with Python. And that's a great course, a great specialization. And it is kind of like, it's baby steps into data science. It's a nice survey across a wide range of data science. And it's not going to turn you into an expert. 5 Coursera courses is about 3 or 4 credits. And so that's really just like an intro to data science course. But the beauty is you can take it from anywhere in the world. You can take it on Coursera, and you can take baby steps down a data science curriculum path. And then you quickly can say, man, I love this. I want to learn machine learning. I want to learn more about statistics. I want to learn database better. I want to learn Jupyter notebooks. I want to learn some visualization. I want to learn all these things. So you get a little bit of all that in Applied Data Science with Python, what we call ADSWAPy. Let me put that in. Applied Data Science with Python. Coursera. You can Google that. We call it ADSWAPy. So you can Google Applied Data Science with Python on Coursera. Chris Brooks is a colleague of mine that put that all together, and I think it's one of the best quick, broad looks at the field. And it's not like you're going to be an expert, but you will have a better chance, a better sense of where that you want to go next. I'm using an old I am using an old application that can only be used with SOAP and XML. Oh no! What happens when you type import SOAP in Python? I wonder if it's even still there. Python. Let me go ahead and see if we can import SOAP. No! I don't know. I'll just leave this here. So SOAP, something protocol, Object Access Protocol. SOAP probably stands for Simplified Object Access Protocol, which is not at all SOAP protocol. What does it mean? So I talk about SOAP. I talk about XML in Python for everybody. SOAP, what's it stand for? What's it stand for? Simple Object Access Protocol. I guessed correctly. I guessed correctly. It is anything but simple. SOAP is the biggest mess the world's ever seen. And so I am bummed that you have to learn about SOAP and XML. If I was forced to use SOAP, and I'm sure someone's going to yell at me for this, if I was forced to use SOAP, I would treat SOAP as XML. And I would avoid to the extent that I could any kind of WSDL, Web Services Definition Language, or any kind of service discovery. Now, maybe if you're talking to a SOAP web service, you have to use that stuff. But in a sense, I think of like a SOAP web service as a really nasty mess. And the software libraries are bad. They're hard to use. They're probably out of date. And so for me, if I was going to, here's a good pitch for object-oriented programming. If I was going to work with a SOAP thing that I had to talk to, I would build my own like wrapper object around that. And then I would treat it as XML, and I would parse it as XML and not think about SOAP at all. Let me see if I can show you some code of mine that uses this technique, but with JSON. And I don't know. I'll be. Let's see here. It might not be there. Oh. Okay. Okay, so let me go somewhere else. So this is a spec that I helped build, the LTI, Learning Tools Interoperability spec. Okay. So this is the code that I use to send grades back to learning management systems. And so let me see if I can show you. Okay, here we go. Okay. So XML, right? XML is this stuff I'm showing you on the screen. It's kind of less thans and greater thans. And the SOAP people would tell you to use a thing called UML, which stands for useless markup language. I don't know. It's a way to abstractly describe what's in an XML message. And then they would take that UML and then they would generate WSDL, which is Web Services Definition Language. And then you would use a library to read and parse the WSDL, and then you would say, do this other thing. And of course, your boss is probably going to yell at me totally when your boss finds out that I told you this, okay? But if something is so horrible, I just find a way to hack around it. And so this happens to just be some Java code that I've written inside the Sakai project. And I go and I read the spec. Let me see if I can even find this spec. We'll see. I probably won't be able to find this spec. IMS LTI 1.1 error message return. Let's see if I can find the spec on which this is based. Now let's go. Let's see if I can find that right there. There we go. Okay. Let me see if I can find a code major. Okay. So here's a spec, and it's giving me this XML, right? And so the XML people would tell me that I need to describe this in a markup language that then generates another markup language that then I use a library to load the second markup language. Then with that library, I can generate this thing, this actual XML. And so if you look at Python for Everybody, I show you how to parse this XML, right? But the problem is that there is the crude way to do it, which is like, go find a thing. And so I could have built this with XSDs, the schemas, and all this other crap, right? But I'm like, I hate that. I just hate it. I got to put like a number in between here. Now, it could be really bad where I just use string substitution to put something in there like, dash dash stick number here, dash dash, and then I use a string substitution to do it, which is so antithetical to what the SOAP crazies would suggest I do. But so what I tend to do, and we'll see if I do it, is I tend to make a string, which is I probably just copied it from this specification and I put the string in here. And so let me go see what I then do with the fatal message. / fatal message. Oh, there I'm doing. Look at that. I'm using string.format. I'm a bad person. I'm a real bad person here. I'm using string.format, and it's replacing these %s's with 3 values. It's kind of like f strings in Python, and that actually goes all the way back to sprintf in C. And so I'm just taking this fatal message, right, and I'm just sticking 3 values in it. I copied and pasted the XML from a spec, and I'm just changing the text. And I'm like, I don't like the people who forced me to use XML, and so I'm going to fight them. And so here's more stuff, and you can see me just taking strings of XML, right, and just poking in the values just to get to the point where I comply with their crazy thing, because honestly, all that confusing generality of web services definition, UML, that actually keeps, it takes a team that's one person could write code and turns it into something that 12 people can write code. And it just wastes companies' times. So, whoa, yeah. Okay, well, I wasn't expecting I would go off on a rant about XML. Let's see what else. So Alfonso, Dr. Chuck, nice to see you. What is your favorite library or module for symbolic mathematics or numeric computation on Python, and why? The answer is I don't know. Right, so my ARC is not doing a lot of computational things in Python. I tend to build web stuff, and I do a lot of utility stuff. I'm not even like a data science wizard. My only contribution to the University of Michigan School of Information's online data science degree, MADS, is SQL, Postgres. I teach a class on SQL, and I'm like, hey, you're going to do data science. Maybe you should know SQL. And so I love SQL, so I'll teach an SQL class, and I'll leave it up to you and all those other teachers in data science to figure out how to best use my SQL. Now, it's a good class. You can also take that class on Coursera as Postgres for Everybody, PG4E. Let me put that down in there. Oops, come back. www.pg, Postgres for Everybody. And that's coming soon, actually, to, let's see if that made it out. Yeah, that's coming soon to edX and FutureLearn. So that's really cool. So that's now on Coursera, but it will also be in edX and FutureLearn, because the edX, FutureLearn, each of them have their own communities, and I want to give my material to as many people as I possibly can. Okay. Oh, Alex Benitez. Hello, Dr. Chuck. Thanks for the time. How can I promote my skills as a programmer in GitHub? Oh, Alex. Oh, Alex. Do I already know you? Do I know you from somewhere? So if I was a beginner and I wanted to, really sort of, where's CSEV? Come on, CSEV. That's what I want, CSEV. So when I hire a programmer, I don't really have to go too much farther than this particular screen on GitHub. We call it the green squares screen, right? Although for Halloween, they made it orange and brown squares. But the green squares, and the cool thing about these green squares is they're basically all the work I have done in the past year. I've committed 1,800 times to GitHub. Some of the stuff is my own, right? Some of the stuff is like my Python for Everybody repository. Some of the stuff is to an open source project that I've done. And like Django for Everybody and the sample code for Django for Everybody. And so basically by me putting my life, the part that I can share in the open, I've got some private repositories too. Like if you look for, where's a search? Like DJ4E-private. And you see there's private repositories, right? And so that's all my solutions to all the homework for Django for Everybody. But basically, I just do as much as I can. I put all my websites in GitHub. I try to get to the point where, the thing I like about GitHub is if I was to lose this computer tomorrow, it's all in GitHub. I literally, I haven't had that panic moment where I thought I lost my computer for a while, but like 6 months ago I did. I was like, I lost my computer, and I'm like, well, all my emails in the cloud, and GitHub's got everything. I'm sure I've lost something. And I've got good backups too, and multiple sites. But so I used to store all my presentations on a folder in my laptop, all of my PowerPoints that I ever did. And now I have a repository called, I think it's Dr-Chuck. Let's see, Dr-Chuck. Yeah, so this is like my stuff. And that's my resume. I have another one called Talks. So that's my drchuck.com page. And so every time I change my web page, I get a little green square in GitHub. And then I have like talks. So every time I give a talk, I have a folder for each year, and you can go see, like 2021, I didn't do too many talks, right? It's kind of low, but like, 2016, back when I was traveling like crazy, you can sort of see every talk I gave. And so I put my life, and I don't have anything to hide. When I gave a talk in 2014 at UCLA, I don't have anything to hide here. And so I tend to put everything I do. And so that means that a person who is trying to figure out like what your tech talent footprint is, all of it rolls up into these little green squares. And you don't have to, some of those I contribute to Sakai, my open source. I have an open source project called Sugi, and those open source contributions as well. And so when I teach, if we look at, DJ Free, right? Let's take a look at DJ Free. I'm teaching this class on campus right now. And my last commit was 3 days ago. And I've done 1,049 commits. Let's take a look at the most recent thing I did. I found a typographical error in one of my handouts for program ads number 1, and I fixed the typographical error. But I did that in GitHub. So I get a green square. I get a green square just for updating a typo in my materials, and I have that automatically go to www.djfree. I just have a process that runs on djfree.com that particular, let's see if that assignment will already be up there. I don't have to do anything. So if I look at ads number 1, see, I think that was the change. Let's just make sure the word admin. Yeah. So that was a typo a week ago, and I happened to see it, showing it to students, so I fixed it. So your original question that I'm answering is, how do you showcase your programming work and creating a sense of portfolio? And I would say GitHub, I think, is the best way. Of course, don't put private stuff or the solutions to every homework you've ever done in a class that told you not to publish them. But everything that you can do in GitHub makes you look better, I think. And when I hire somebody and I take a look, it makes it a lot easier if I can look at your green squares, because I can see not only what you've done for yourself, but I can see the contributions that you've made to others as well. Or if you did just a silly little one-off prototype project, I don't know, I got 156 repositories. Let's just kind of go down. Is there anything that I did? I'm sure if I go down, yeah, website. Oh yeah, these are Sugi React base. Those are things I was playing with. Oh, this is the live page I use as a countdown timer for the live events, which we're in a live event right now. Full calendar. That's a fork. I fork somebody's stuff. So Zap. That probably is something I did that was really silly. What did I do in Zap? Oh, I was trying to figure out how JavaScript workers were working, and so I put it in. And I just wrote a thing. I'm like, well, I might as well stick that in GitHub in case I delete it or whatever. And so I just put my life into GitHub, and it's a good way to show how much game you have. Okay. Why is MD5 not a good encryption? It says K4000. Also, isn't it easy to figure out which part of the passwords is salted because it'll be repeating one part? I just learned encryption recently. Okay, and I'll come to this one, Basamita, in a second. So the reason that MD5 is not a good encryption standard is that the key to the quality of any hashing function is the likelihood of collisions. So if I take, I've got 2 pages. I got the hidden figures from Wikipedia, and I've got Margaret Hamilton from NASA Wikipedia. And I take all this text and I run it through a hashing function, and it comes up with a hash. And I take all this text and I run it through the hashing function, and it comes up with a hash. If these 2 pages give the same hash, that's not good. Now, this is a lot of data, right? And this is a lot of data. And so the hash is naturally much smaller because the hashes are fixed size. And so there's going to be collisions. The problem becomes not so much that there might be collisions, because no hash is perfect. They're really rare. Collisions are really rare. The problem is, if I can take this page and calculate its hash, and then I can take this page and add some stuff to it to the point where I have forced it to make it so that this page hashes to the same value as this page, I have then consciously broken the hash. So if we think of this as your password is hidden figures, and my password, I want to break into your thing. My password's Margaret Hamilton. Well, no, think of it this way. Your password says hidden figures. You're using MD5 hashing. The system's using MD5 hashing. And so your password's hidden figures. And I can take and put in something else, big long thing, that when I type that password in, it might be 10,000 characters or it might be 3,000 characters. I type a 3,000 character password that I know what your hash is of hidden figures, and then I match it. And so the better hashes make it more and more difficult for me to construct a piece of input that collides with a hash on purpose, because I know what your hash is, because somehow I've got my hands on the hash of your password. And the salt is just a way to make that much more difficult. The other thing that the salt, you mentioned salt in your question. The other thing that salt does is it solves the problem of what's called rainbow tables. And so on MD5 hash, I probably can't find it fast enough, but when I talk about it in one of my classes, you can Google rainbow tables. And what rainbow tables do is they pre-compute all the hashes for a short string. So if your password is hidden figures, and I go and I spend like a week and I run a long loop and create a really large database and compute the hashes of every word and every 2 pair words, and then I can put in a hash and go back and say, look, hidden figures will mark to go to that hash, right? I can look up instantly. I can reverse engineer a hash, and rainbow tables is the technique. Now, why is the salt important? And you say, well, the salt's repeated, so that doesn't cause a problem. Well, it does make rainbow tables completely obsolete, because it takes a long time to compute a full rainbow table. But if you add a salt, even if it's a couple of characters to the beginning of everything, then if your password is hidden figures, but then I add XYZ hidden figures and hash that, well, then they can't make a rainbow table of XYZ and every word, right? So the purpose of salt is to make it so rainbow tables is a bad solution. So go Google. So if you're interested in MD5 and cryptography and salt, and why MD, just search MD5 collision, and what you'll find. Now, one of the things, it is, if you took a cryptography class, I'm sure your professor got all up in front and said, MD5 is bad. It's really bad. The answer is no. MD5 is bad for high security crypto situations, but MD5 is not altogether horrible. The key to MD5 is if I can figure out what your hash is, can I construct a plain text to get to your hash? MD5 is easier to do that. But in the example of your password is hidden figures, and I construct a 100 megabyte password string, most places will not allow you to use a 100 megabyte password. So just because I can break MD5 and I can come up with a string that comes to your same hash, so the question becomes, if I'm coming up with sort of like an evil string trying to get to the same hash, it's really hard, and usually those strings are pretty big. Now in MD5, they're smaller than like SHA-1 and others. All these hashes are vulnerable to this, but it's easier to figure out for MD5. But if you're just using something like you're trying to make a hash of URLs, they just don't collide that often. These hashes, even MD5, are fine if all you're doing is like non-cryptographic things, and you're like, is this document the same as that document? Or I'm building a caching system to retrieve web pages and see if it changed. Well, retrieve the web page, compute an MD5 of it, stick it in your database. We're not talking about security here. We're just talking about stick it in the database. Then retrieve it again, compute the MD5, and if the thing changes, then the page changed. And so you can use MD5. And so you will see in my code, after all of this, there are times that MD5 is just fine. It's just fine. Not security, not passwords, but it's just fine. So I consciously, to annoy people, I use MD5 in places where MD5 is fine to be used. Strings have a finite length. The users can't change the strings. I'm not doing cryptographic hashing. So so there you go. Okay. So, Basamita, good morning, Chuck. I was looking for C programming for everybody. I have an account there. Can I get an invitation to join the course, please? So C programming for everybody. C programming for everybody is C programming for everybody is www.cc4e.com. And so cc4e.com is the next course I want to build and I want to teach. And there is no invitation required. You just have to break the code to get into this class. So the unlock code is a number, and I'll just guess 42, and son of a gun, there I am. And so you have to unlock CC4E. And that's because it's like pre-emergent. The problem with CC4E, and I talked about this like a couple of months ago in my office hours. The problem with CC4E is it's really under construction. I just have one thing, and when you log in, you can do one thing. I made a lot of progress like in August, and my goal was to teach this in September and October of this year, and I didn't make it. I did not make it. But what I did was I built a whole bunch. This might not even work. Let's see if it works, because sometimes it times out because it's a little slow. Yeah, we'll wait a second and it won't time out, I think, the second time. So I built amazing technology to prove I could do it, and then I had to actually build the course. And I just ran out of time in September and October to advance what's in here. So if you're asking, let's see if it works this time. Still Docker error timeout. Well, we'll see. Usually maybe the Docker thing is down. I gotta fix it. Come on, Docker. No, I gotta go fix it. So the problem is, going back to the problem is I just haven't made as much progress in CC4E as I had hoped. And I taught C programming in 1991 at Michigan State University in the fall of 1991, and I have all the assignments from that. If you go to, I think if you go cc4e.com, is it ASSN? Here's the original assignments. So if you go to cc4e.com/orig, you can see the assignments that I actually gave that were due in the fall of 1991 at Michigan State University in a place called Lyman Briggs. It was the first course I ever taught. Well, no, it was my first MSU course I ever taught. And I wanted to do it 30 years later to the day, but I couldn't get there. I just got busy, and my first priority is teaching my on-campus courses here at the University of Michigan, and so I'll get back to it. And I'm honestly, that brings up a really important question. I'm not sure that calling this CC4E, like all my other classes, is a good idea. So the question is because I'm not really teaching C. I'm teaching sort of, I guess the name that I would name this course would be Understanding the Formation of Modern Programming Languages by looking at the C language during the 1970s. So that's the name of the course. So I'm not really trying to teach you C. I just think very few people are going to learn C, and very few people actually work in C, unless you're going to work like in the Linux kernel or something, or work in the core of Python, which is a tiny, tiny fraction of people. I mean, you might as well go get a computer science degree if your goal in life is to work on Linux or work on Python itself. And that's when C is essential, and C and C++ are essential, and that's deep skill. That's really, really deep skill, way deeper than Python. And so, I don't want to teach the C course. I want to teach a course that teaches us about programming, but by looking at C. And so can somebody come up with a better name than C Programming for Everybody? If so, let me know in the comments. I mean, so one name that I've come up with that I don't think it's going to work is, I'm going to call it, yeah, it's a really long name, a DTF. Yeah, that's why I don't like it. That's why you got to help me. So another name I've come up with is kind of a silly name called Modern Programming. Because it's not really modern programming, it's how we got to modern programming. But the reason I like modern programming is it is a homage to one of my favorite MOOCs in the universe, and that is ModPo, Modern Poetry. And so I just want to call it modern programming. But it's a misleading, because it's really the history of modern programming is what I want to teach. History of modern programming is what I want to teach. How we got to now. It's not modern poetry, and it's not modern programming. Although eventually, if I follow all of this sort of to its logical conclusion, and I teach, let's call it modern programming in C, or no, not modern programming in C, just modern programming, or the origins of modern programming. That's a good one. I'm going to write that one down. The origins of modern programming. The origins of modern programming. So eventually I'm going to teach this class, The Origins of Modern Programming, using C. And then I'm going to teach a class probably about, and I've talked about this before, a hardware and computer architecture class that's really simple, an assembly language class, and then a Java class. And then once I've done that, to actually move you from learning base skills to learning how to become a high-quality professional programmer, the thing I'm thinking about doing there is what I call the Programmer Studio, where it's an invitation-only class where we meet, say, 2 hours a week, and we just watch each other program. And to become a true professional programmer, whether you're hired at Facebook during those first 2 years, you learn from a mentor. You learn from, and it's not that different than a poetry studio, where how do you really get good at doing poetry? Well, you write poems, but then you need feedback on your poems. And so I want to do that with programming. And here's an interesting observation, and that is I've been wanting to create this inside the Programmer Studio for a long time. And I wanted to use my Sakai open source project to do this. And we actually have scheduled a number of times, like Wednesday mornings at 10 o'clock, was supposed to be like Sakai programmer office hours. And what I want to do is invite the world to watch, because when we work together on really complex software, I think it's pretty fascinating. And I think there's stuff to be learned from that. And so we schedule these, and I'm saying, okay, I'm going to invite everybody to come to one of these things. And then the people coming that are part of the would-be mentors, they're like, this week we're going to work on something kind of ugly, And I don't want to, let's not invite the world to this one. Let's just invite 4 or 5 people to this one. And this happens over and over and over again. I'm trying to create inside the Programmer Studio, and the people who I want to record are, the best way to put it is they're gently ashamed of how hard it is to do that which they are the world's expert in, if that makes any sense. And that is, these are people I look up to because they have the answer for everything. But what's oh, we got to move this. We got to move this, don't we? Move the mouse. Uh-oh. Uh-oh, we got to move the mouse in the background. I don't know what to do here. Uh-oh. I don't know. Can you? Okay, you're fixing it. Okay, you're fixing it. So it's being fixed by the hidden figures in a control room. So, so the problem is, and this is true for me, I always want to live stream my own coding. The problem is, when I'm solving a problem, there's really 2 phases to it. The first phase of when I'm solving a hard problem, I'm not particularly proud of what I'm doing, and I'm not sure I'd want to record it, because I swear I get mad. I am so frustrated because I'm just struggling to find where the problem starts, right? And so this is the essence of advanced programming, is you get to where the programming starts, where the problem starts, and you're like, what, over here, over there? God bless. What is the problem even? And so it's just so frustrating to find your way to the problem. And then once I found my way to the problem, then I kind of like, oh, I know what I'm doing. I'm going to do this and I'll do that. And it might take me a while to solve it, but that's when I want to show you, as a student, I want to show you what it is that I'm doing. And what I'm showing you is the part where I'm like a superhero, because I'm like, oh, this is a really hard problem. Watch me. Watch. Oh, see that? Oh, I guess we didn't do it, but watch me. I'd change this other thing, and then it'll be great. And then you see me as like this, invulnerable, perfect programmer that just kind of seems to know everything. And that's the part that I'm willing to stream live for you, is when I'm a wizard. What I won't stream live for you is the misery, the 2 hours of me being super wizard versus the 2 hours of me feeling like I'm dumb and I'm never going to figure this out, and getting mad and going to have to take a walk, right? And so what I want to do is I want to figure out a way, and this is the Inside the Programmer Studio thing, I want to figure out a way so that some of these super smart people don't feel so vulnerable when they're exposing the confused parts of what they're doing. And so that you, as a person who needs mentorship, you need to see how hard it is to do what we do. And here's the thing. We know, me and the other senior people, we know we're going to win. We always do. We always succeed in finding the problem. There is no problem that sometimes got to ask somebody else, but eventually there will be a reason for this. You may be looking in the complete wrong part of the code, but eventually there's a reason. And once you see that reason, then it's just like you're going to build something and you're going to fix something and you're going to put an if statement in, or you're going to do this thing. And that's the crafting of the solution. But the harder thing is the puzzle, which is the problem. And I think I can get there. I can't just like snap my fingers and say there is a thing called Inside the Programmer Studio. I can't just tell these people to trust the attendees. We'll get to the point. The only way inside the Programmer Studio can work is if it's invitation only. And if you have to be qualified and you have had to made some commitment to be in the studio, right? You can't just go and say, I just want to listen to poetry. And the answer is no, you don't get to come in the poetry creation studio if you just want to listen. So you can't lurk. And so that's my idea. Yeah. So what could you do for a programming studio that is not live streaming and solve the problem with complete strangers? I mean, Milad, that is the idea. You're quite right. And live streaming coding is what I'm trying to get at. But the problem is that I think that too many people, when they live stream code, live stream things that they're good at and have figured out the hard parts before they turn on the stream. And what I want to do is I want to turn the stream on earlier. I want to turn the stream on during the time that you're not an expert, even though you will be an expert in an hour. And so the struggle is the hard part. When you are confused and you're researching and trying to understand, yeah. So, yeah, I'm screaming in my mind. Yeah. Okay, let's see what else we got. Foundation of programming. Okay. Basamita, thank you. Foundation of programming. You know what I like about it? I love your idea. Whenever I say foundations of, I want to say foundations of computing. And that bothers me because foundations of computing sounds like too much math. But foundations of programming gets where I want to go. So I got that one written down as well. I know, Zach 4000, I can live stream and code on Discord, but I won't do it until I'm half done. You only see the easy half. You never see the hard half. Yeah. Yeah. Let's see what else we got. Cheers from the Netherlands. Netherlands will probably be one of the places I go. Yeah, you can't, or I don't know if you can see my screen or not. I don't know what we're taking right now. Yeah, someone was asking about UIs. I'm not an expert in that. Unified modeling language, yeah. Oh, someone says, Dr. Chuck, do you see that PHP is important and powerful? That's a good question. A good question is, why is PHP still relevant? And I would say yes, for the following reason. And so I teach a PHP class, Web Applications for Everybody. I'll go put that in. Web Applications for Everybody. I think it's one of my best courses, but not everybody thinks so. A lot of people take it because they're going to go work at a place that does WordPress. So PHP, if we go all the way back to the history of PHP, which is over 20 years old now, PHP was kind of a templating language in the server and a way to talk to the database and retrieve database and then format that up and send HTML out. I think that if you were looking to move forward, you wouldn't build a traditional server-based PHP application anymore. Yeah, with things like React, you almost have to build something on the front end that works and looks like React or whatever comes after React. The time for purely server-based rendering there's still lots of legacy code that does it, but I'm talking about a fresh start, right? I'm talking about a fresh start. I just think in a fresh start, you can't say server-based rendering is the future. It's not. And I'm not sure jQuery is the future. I think jQuery was our way of getting to the future. Web components, they might be the future. I mean, the browsers are getting better and better, and as it becomes easier and easier and there's more tooling inside of servers that makes it easier to do web components, server-based rendering is really, I think, not long for this world. But for a long time, I was a server-based rendering person, and I did not like React. And I have, in the last 3 months, I have kind of come to a new understanding of the fact that React is mature enough now that I can use it how I want to use it rather than it telling me how to write code. I'm like, I want to use React to do this. I still think React has a long way to go. The wiring up of the data is still counterintuitive to me. I mean, you still have to do a little too much work to get your data to work. Things like GraphQL or something I think we all need to understand better. And I don't like building new stuff with technologies that still feel ragged to me. GraphQL still feels ragged to me. It's hard to build, it's hard to use, and that doesn't mean it's not awesome. It just means I don't have time as a part-time programmer to learn enough GraphQL to be productive in GraphQL, which means you got to work. Now React, I can be a part-time programmer because I am always going to be a part-time programmer. I'm a professor, that's my full-time job, and so I'm a part-time programmer. And so React, I can leave it, and I can come back to it and figure it out. GraphQL isn't like that yet. It's just like, come on, make it easier. Just quit making it so difficult. React has been done by enough people and enough beginners are starting to reuse React that React is more accessible as a way to write code as people will write React and nothing else. But your question was not about React. Your question was about PHP. So the question really becomes, you've got a database and then you've got React. And the question is, what's in the middle? Is what's in the middle Node? And I'll be honest, JavaScript's a fine language. It has some of the coolest object-oriented patterns. I think Node as your runtime server is still a non-starter. I just think that the Node people are too into Node and too into the JavaScript promise crap that they just make programming too hard. And so while you might not be doing the markup in the server and the rendering in the server, that's going to be something like React, there's a place for PHP in the middle. And in the middle, we're not talking about the user interface, but we are talking about that layer that logs in business logic, decides what data to show you, et cetera, and then perhaps using something like Laravel Web Services to do your REST work so that then the REST data can be sent to your React code. I think PHP still has a lot of benefit when compared to things like Django or Flask or even Java. And the key thing is not so much is PHP good or bad. PHP is amazingly low overhead compared to a lot of other frameworks, right? And the other thing I like about a PHP is you don't have to immediately go to kind of this weird microservice architecture. So for me, I don't like Flask. I don't hate Flask. I just feel like Flask pushes you toward microservices. And I don't like microservice architecture because I just think that that's too many like moving parts that will age in different ways, and you need too many programmers to run a microservices architecture. And so I'm working on a new project. And for me, and believe me, I tried to use Django for production stuff. And I tried for 3 hard years because I built Django for everybody, and I thought that was the future of all programming was going to be Django. And I have not been able to make Django go fast the way I have been able to make PHP go fast. And so I can deploy a PHP server in production like that. I can scale it like that. There's so many things that make it go fast. And I don't have to be a genius to do it. That's the key. I could do Node. I could maybe make it go fast. I don't even know where to start to make Node go fast. The same is true for Flask and Django. But I know how to make PHP go fast. I know how to make Java go fast. Java's more complex. Java basically, a PHP programmer, if they're worth $70,000 a year, then a Java programmer's worth $120,000 a year. That's why I'm going to teach you Java in the future, is because you can make a ton of money in Java. And Java's not a bad scheme, and Java's evolving a lot. And Java's influenced by like things like Scala that came out and threatened it. So Java's moving. Java's not as the same Java as it was in 2002 when I first started learning Java. But to answer your question, I suggest you learn PHP. I suggest you take web applications for everybody. And even if you never do PHP, that course will be useful to you because it's kind of like the gritty low-level stuff that is web applications. And it gives you a way to think about, no matter whether you're using Node or whatever, sooner or later you got to figure out the low-level bits. My country's banks are introducing WhatsApp as banking as a product. Would this be a security risk as Meta may have built backdoors into WhatsApp? Yeah. That is So banks are going to make decisions that banks make. They just are. And, you know, we use credit cards, we use apps, we pay stuff online. I don't get too upset about things I have no control over. I can't influence banks. I can't tell them what to do. Privacy, data security, WhatsApp for banking. The key thing to banking is banking's going to use technology that makes our lives convenient. We walk around with credit cards, we put them in machines, our lives are convenient. By the way, they're like working on credit cards, getting rid of there's laws in the United States where there's a law that says every place that accepts credit card has to accept magnetic stripe, which is the least secure way to do credit cards, other than typing the number in by hand. And they're gonna make it so you have to use chips or little wireless stuff, which is way more secure than it. And so banks are willing to tolerate a certain amount of things that go wrong. The problem is if you're going to get your identity stolen, and WhatsApp, exposes your identity in a way that it harms your banking. I honestly don't worry about Facebook stealing my banking information or WhatsApp stealing my banking information. I do worry about people who want to steal my banking information tweaking Facebook or tweaking WhatsApp and using WhatsApp to get at my stuff. But I'm less worried about the companies themselves. I just don't think that Meta, the new Facebook, if they wanted your banking application, we already have microphones in everyone's house, and you're sitting on the phone and you're reading your credit card number on the phone to somebody because you're doing whatever, and this little microphone's listening in your house. You think Amazon couldn't have your credit card? Oh wait, Amazon already has your. So, banking, other than identity theft, and the key to identity theft is not that WhatsApp is the vulnerability, it's what you do with it. Someone sends you something in WhatsApp and you click on it. My wife, what was it? Oh, I know what it was. She always asked me about phishing stuff. And so she got an email from a local store that says, you have enough points that you have a $100 credit. Click here. And so she's like, she knows. Ask Chuck if there is any email message that eventually says click here. Don't click, right? When it says click here, don't click. So I'm like, and she said, they've sent it to me a couple of times. It seems legit. And the thing about the points, I have shopped at that store a lot, and I think it's legit. I'm just wondering what I should do, right? And I'm like, don't click it. The rule of when someone sends you a link, don't click it. That still is a good rule. And even if it's totally plausible. And the reason is if I'm trying to break into your thing, I will send a plausible message. That's the whole idea of phishing. If I send it like, hi, only people who are fools will click below because I'm about to steal your data. Click here. No, that's not how we do it. Well, not me. I don't do that. But bad folks, that's how they do it. They give you plausible messages. So you can't look at the plausibility of the message as the reason to click on a thing. So we're in WhatsApp and you got a plausible message like, your bank says you have a bonus. We're going to pay off $50 of your credit card. And you just click here and it seems like it came from your bank. It's plausible or whatever. You got 12 months of on-time payments. And so we're going to give you 2 months of no late fees. Click here. And it's like, well, I did do 12 months of on-time payments. And I heard about that thing on TV about the no late fees for 2 months. Sure, no, don't click. So I told her, I said, look, if it's really the store, I want you to walk in that store and I want you to show them your little code and I want you to say, do I have a $100 gift card in this store? And if they go like, what $100 gift card? Then you're like, good thing you didn't click, right? So I don't worry about Facebook being evil and snagging your stuff through WhatsApp or whatever it is. I don't worry about WhatsApp itself stealing your stuff. I do worry about WhatsApp and Facebook being manipulated by others to get you to use that platform to click on a phishing thing or whatever, right? So I don't worry about Google wanting to steal my phone, my phone number. I don't worry about Google stealing my banking. I don't worry about those companies doing it. I do worry about the platforms being used to get at me to steal my stuff from. So they're just being an intermediary, when someone who wants to take something away from me. And so things like privacy and data, I just assume that banks, as long as you don't get phished, banks are going to make decent choices as to what the risk benefit is. And if they start losing a bunch of money and things go bad, then that bank is going to change how they do business, right? And historically, banks have not been, they have made our lives very convenient, and they've had just enough technology to stay one step against the bad guys, for the bad guys to just go get to the bank or get in between us and the bank. That's not that big of a problem. The big problem, of course, is us phishing and clicking on stuff and whatever. The big problem is us, not the interaction between us and the bank that's getting somehow in the middle, a legit interaction that's somehow getting corrupted. It's an illegitimate interaction that looks legit. And so I don't worry too much about that. I worry a lot about us putting microphones in our houses because you say, I want to order more toilet paper. Hopefully no one's listening to this that just bought some toilet paper. But that amount of convenience, I'm sorry, I don't want to say turn the lights off. Hopefully these studio lights are not hooked up to Alexa. The whole notion of the convenience of having an always-on microphone in your house, that makes me crazy. Hi, phone. I don't know what this phone is listening to, but whatever. I got not too much to hide, but I don't like the idea of crossing. I do have a ring in front of my house, but that's pointed at the street. If you walk by my house, someone might see you. It's okay, hopefully. So, okay. So I've been learning Django for quite a while. So after what you said, should I stick with Django or switch to some other web framework? What about .NET or Go? I'm going to guess you're saying, yeah. So I would say this. I've been learning Django for a while. After what I said, should I stick with Django or switch to some other web framework? What about .NET or Go? The answer is you should always learn more than one framework, even if you learn Flask, right? Even if you learn Flask. And, the more frameworks I learn. I'm not a fan of Ruby on Rails. I taught Ruby on Rails here at the University of Michigan in like 2007, 2008. And I'm really, really thankful that I learned Ruby on Rails and taught Ruby on Rails, because there's some things that Ruby on Rails has taught me and the entire development arena in terms of web applications. Things like Laravel or Cake PHP are totally inspired by Ruby on Rails. There's things in Django that are inspired by Ruby on Rails. And so everything that you learn, if I was going to write Node and write throwaway code, I'd be fine with that, right? I just don't want to write Node and be stuck with having it to slow down. All of a sudden my app is successful and it's the database or the server slowing down, and I'm like, now how do I make this thing go faster? I know how to make Java go faster, and I know how to make PHP go faster. So for me, I'm going to lean on, and I know how to make PHP go faster for a very, very long time. I don't know how to make Node go faster. You may, and others, or you may be able to hire somebody for $150,000 a year who can make Node go fast. Great. They're probably going to create some crazy Rube Goldberg Node scaling contraption crap. I don't know. I know how to scale PHP. And again, you have to understand that I'm a part-time programmer. I'm a part-time, I'm a part-time programmer, and I'm a part-time system administrator, DevOps. And I have a company, and I have all these servers for Django and Python and all these things. There's my servers. I'm the only one. I don't have like a big team of people doing stuff. And so I have to choose technologies that work for a very small team, which is like 10% of me is the size of my team. A lot of that production stuff I haven't delegated to anybody. There's other things that I do delegate to other people, but not the production stuff. I just run it myself. I go to Amazon, log in, make EC2 nodes and databases, and I'm it. And I get like maybe 2 hours a week to work on that. So I don't have time to go study what it takes to make Node go fast. I know how to make PHP go fast, and I can do it in 1 hour a week. I don't want to become a Node wizard. I just don't. I don't. I tried. I gave it a go, and I didn't like Node, and I certainly don't like Mongo. Okay. Metaverse. What are your thoughts on the metaverse? So Rob, are you aware of any funded opportunities with your team at University of Michigan for promising talent outside the U.S. or perhaps a sponsored PhD or other scholarship? So Rob, I don't have any PhD students. I tend not to. The reason that I don't do any PhD student work is because part of, if you were going to advise a PhD student, you want them to graduate and succeed, and success in getting a PhD is not something I have a skill, and I consider myself lucky to have gotten a PhD myself, and I don't feel like taking on the responsibility of mentoring somebody else to get through what is an almost impossible set of constraints to finish a PhD. And a PhD is, for me, completely opposite of where my interests are. Research as classically defined in any field, whether it's computer science at School of Information, I find beyond dull. I find it super dull. And that's because you're looking at something that's so tiny, and the audience that's listening to you if you make progress is also so tiny. There are like, I don't know, millions and millions of people who have touched my Python classes. That's what I want. I don't want to go narrow. I want to go broad, broader. I want to influence the world. So I don't do PhD. And we don't generally fund master's students. What I'd like to start doing is I'd like to start hiring, as part of this like Programmer Studio thing, is I could hire master students. But the problem is by the time a lot of master students get to the university, they're funded enough through their parents or loans that they really don't want to get distracted from their education by working for me at like a $20 an hour job here in Ann Arbor, Michigan. And so that doesn't work so well. And so I working for me is difficult. The closest thing to working for me would be to get involved in an open source project like Sakai, and I spend 20 hours a week with many meetings, and so but you're not going to get rich off of that, and you're not going to further your education because no one really cares about a PhD in programming, which is what I want to eventually show you, a PhD in programming. But we don't even have a bachelor's degree in programming, let alone a master's degree in programming or a PhD in programming. But hey, I got 15 years to work on that. So what are your thoughts on the metaverse? It's so popular nowadays. How can we adapt ourselves to the future? Yeah, Facebook, of course, announced its new name called Meta, and I'm very happy with all the funny memes. The funniest one I saw recently was feta, where it's a block of cheese, so it's a block of feta cheese, and so I thought that was pretty funny. So I think that I guess I'll think about Ready Player One, and I'll think about the concept in Ready Player One called the Oasis. And so what's interesting, say in Ready Player One, is the extent, not just that we can do gaming in the metaverse, but can we do things that are like life in the metaverse? And I see so little. I see absolutely so little that the metaverse adds beyond what we're doing right now, which is simply video streaming. It's like when Second Life came out, what did people do? Well, people built rooms, and then they put YouTube channels on the wall, like a TV. So we all go to a virtual sports bar with a bunch of TVs on the room, and then you can watch whatever TV thing you want. It's like, really? That's a step in the right direction? I mean, you can watch on your phone in a bus, right? You can watch a. So now we're going to put this thing in a metaverse, and I can walk around in a 3D thing, and I can't even see the people behind me unless I turn my head around. I really wanted to do office hours. I bought like every dumb Oculus you can buy, and I'm literally going to throw them away. I have like 2 Oculus, like an Oculus Go and an Oculus Rift. So I've probably got $1,500 into Oculuses. And my son, who bought them too, and he was showing me all the cool things you could do, and then I would see all the cool things I could do, and I'm like, there's just nothing useful in here. And so I think the problem with the metaverse is that nobody seems to be interested in building a metaverse that augments the reality of people working together and doing things together and looking over people's shoulders and being in this same facility. I went, was it last week? No, 2 weeks ago, I went to Philadelphia. The first trip that I went on. Let me see if I can, don't take my screen yet. I'll show you some pictures of it. Don't take my screen yet, because I got to get to the right place. Don't take my screen yet. Don't take my screen yet. There we go. I am going to get there. Okay, we're almost there. Okay, now you can take my screen. Okay, so I went to a conference in Philadelphia called EDUCAUSE, which is a conference. Okay, a conference called EDUCAUSE, which is a conference that here you can come back to this for a little bit, and I'll intro it, and then I'll come back. And so EDUCAUSE is a conference that I've been going to for 20 years now, and it's great. And the coolest thing about EDUCAUSE is it's a conference for like information technology professionals in higher education. And there's some talks, and that's fine. I'm sure those talks are good. I don't really care about the talks. The people who get to give talks at EDUCAUSE just mostly are a bunch of people that have politics and kiss a bunch of butt, and then they can get in and give a talk, right? The real action at EDUCAUSE is on the trade show floor. And like EDUCAUSE has 6,000 people, and sometimes 2,000 of the 6,000 people are vendors on a trade show floor. And I, of course, am the leader of an open source project called Sakai. And we thought, oh, we're open source, we're free, it's tacky to go and be a vendor on the floor. And the people who thought that was a bad idea are no longer part of the project, thankfully. And so I'm like, I'm going to go and take some of the people that work for me on Sakai. So I employ people on the Sakai project, and I'm going to take them to a trade show, live the trade show experience. It'll be the first time I've ever built a trade show booth and been in the booth. And so we didn't want to fly, and so I rented a minivan. And we drove to Philadelphia with 4 people straight through, and it was raining. Minivans are amazing, but the rain was like, oh, this is scary. Scary to drive 10 hours, 6 hours of which was in the mountains and in the rain. So let's take I'll show you some pictures of this, and I'll narrate what went on. So if you take a look here, you can see this is the minivan, and you can see that I had all kinds of swag and giveaways, and that the black box on the right hand side, that's the trade show booth. And so you get in the trade show, and because you're a vendor, you get to go in early, and you get to do all the setup. And so this thing is like a bunch of Lego pieces that we all put together. And the people on the screen are, all these people work for me. Mark works for me as the Director of Quality Assurance for the Sakai project. Brent is my son, and he is our social media marketing intern because he's going to school, and so I'm his internship. And he's got cerebral palsy. You'll see him in a bit. He's got those crutches there. And then the guy on the right, his name is Chris Knapp, and he works for me in Sakai in the area of accessibility, and he's legally blind. Now, he is legally blind. He can see it. He can see light and dark, but he can't read anything. So he can see the little tiny bits of light and dark depending on the lighting conditions. But he's just like, he's he's like an independent blind person. And so he's like, I'm going to help you put this booth together. And so he was like feeling it. And so we're putting the booth together. The whole place is empty, and we're assembling the booth. And there's me assembling the booth. And we're just like looking at all the numbers on this thing to set it up and put it together. And we figured it all out. And there's Mark and Brent and me working on the booth. And at some point, I hope it comes. Okay, now it's starting to come together. Once you get a few of the pieces together, the next pieces fit together pretty well, and we're going to stand it up. And then we stretch this cloth over, the stretchy cloth over everything, and then we kind of put it all together. And we're putting a TV stand on, and then now it's kind of in place in the booth. And oh, there's Mark. You can see everyone just ships all this stuff in a trade show. It's so fun to go to a trade show floor and go in the back and be a vendor rather than just be like a watcher. That's Mark taking a picture of Chris Knapp. These pictures you're seeing, the blind guy took the pictures. So there you go. The blind guy's taking the pictures. So he somehow just hears it and take pictures, and then Mark takes a picture of the blind guy taking a picture of Mark. And then here we are starting to put it together with a TV and a little booth and some chairs and stuff. And yeah, we're almost there. So that's Mark and Brent at the trade show, right? And away we go. And so that's Chris Knapp at the trade show and booth. And then I think there's just the trade show booth, and there's one of our competitors. Yeah, we had a drink. And then they had an Iron Man thing that's another of my competitors. And then now you see Brent talking to an actual person at the trade show booth. And that's not competitor. That's some friends that know that I know that. And we went and did karaoke and had some beer, some more karaoke. My son sings metal. And so he was singing some Disturbed there. And so I think that's I don't know what happens next. Oh, that's me. Oh, I wear my racing suit around to get some attention, and so we went to this conference, right? And we drove in a minivan, and we spent a bunch of money for the trade show space, a bunch of money for the booth, and then we did karaoke, and we had drinks, and we had dinner. And that's the first time for me to be around people since March of 2019. It was the first business trip I'd taken. I even thought about meeting some of you in downtown Philadelphia. I thought about having office hours. I was running this whole thing, so I didn't really want to think that through. One of the nice things about this conference is they required a vaccination of every single person who came. And so what we found was over time, like over a 2-day period, we knew that everybody with a badge, and you see the badge hanging around my neck, everybody with a badge had a vaccination. And people they weren't taking their masks off, but they were starting to feel okay, right? They were feeling like, we're with people. We're in a space. We're in a reality metaverse. That's what this is about, the metaverse. We're in a space together. And I can overhear conversations. I can see people walk by. I can have conversations. I can have conversations with the team that I brought with me. And some of these people, because we all work remote, I don't see very often. And the energy that came from the mere act of being together after all this time of being apart was amazing. And then when you talk about the metaverse, I'm like, I have never seen a virtual reality or extended reality or augmented reality thing that on a scale of like a 1 to 100, if this little thing I went and did in Philadelphia is 100, I've never seen anything in virtual reality, whether it's Second Life or the best thing Facebook has to offer, that is even 1% as good as reality. It's just such crap. And then what happens is the things that I have seen that feel the most like that feeling of being in a place with people is actually 2D experiences. So there's actually a little startup company that was kind of behind me where I'm standing there. And they're talking about this thing where you just drive avatars around a 2D room and you can overhear conversations. And this concept of location and overhearing and looking over someone's shoulder, and I think there's so much to that. But every virtual reality thing I've ever seen just doesn't give you even the beginning of that. And so, yeah, metaverse, great. I'm going to guess it's just going to be crap. It's going to be really good for gaming. And, you know, we have so far to go, and we have a unique moment in time where we have been isolated for a long time. And we need to think, all of us need to think as we become unisolated, what it is about the real world and being together that if we are ever going to make a metaverse, what is it about that being together that we're not capturing? What is it? Zoom's amazing. It's amazing. I love it. I get so much done. It's good for meetings, but it's not good for shoulder to shoulder interacting. So I don't know. I think the metaverse has been around forever, and I think it's been crap, literally forever, for anything except for gaming. Right? So that's my feeling on the metaverse. So yeah. No, Rob, I buy the beers. I'm a one drink person because usually I'm driving. So I have a drink and then never a second drink. Yeah, SQLite is great. Your folks in the chat are talking. Jimmy, please continue this live Q&A even after COVID. Absolutely. I'm going to keep doing this. And then what will happen is if I'm back to after COVID, then I'm going to mix it, right? I'm going to mix it. Because that'll make it even more interesting, right? If I was to gone somewhere, if in Philadelphia, I had met with a few of you and we had a little bit of video and I brought it back and we could show the video, it'd be like, oh, that'd be so cool. Yeah. So Alex, what about Golang, Dr. Chuck? So I am not a fan of new programming languages, at least from the point of view of making any kind of commitment to new programming languages. So Go is a good example. Scala is a good example. Rust is a good example of new programming languages that claim to show us something we've never seen from other programming languages. And I don't disagree with that. I don't disagree that there are things in Go that we might not have seen in any other popular programming language. The same with the Rust, the same with Scala. And that's like saying Node is no, do we all have to switch to Node, or are there a few things that Node can teach us, right? And the answer is all these new, innovative, cool, upcoming, emergent things teach us much, but that doesn't mean that they are the long-term answer to convert to. And so I'll be honest, I want all of you to go start using Go so that then Java and PHP and Python, which are the things I want to use, look at you and go like, oh, wow, we're losing people to Go. What is it that people like about Go? And then they come back and they add whatever you like about Go, they add it to Java, PHP, and Python, and I never had to learn Go. I just wait a year and everything that's cool about Go will be in Java. Java right now, Java is the weirdest language evolution. It really is weird. Java is like so not cool compared to a lot of other things. And yet, if you stick with it, it just gets so much better over time. And there are so many things in Java that I absolutely dislike. But then I wait and I like work around it for a while, and then Java does it better. And I'm like, whoa, I guess I'm glad I stuck with it. And so the problem with all these things is I just don't think they stick. They are sexy, they're cool, startups like them, and that gives them kind of an impetus. But ultimately, if you look at a programming language like Go, 90% of it is the same as every other programming language, and 10% of it is something cool, like Rust. Rust probably has some performance benefits, right? But what's stopping Python from figuring out how to, if it's just syntax and a runtime, Python can steal all those ideas. And JavaScript is, and JavaScript is one of the languages that, as far as I'm concerned, it's a forever language now. But JavaScript is so fast, to say, oh, we got to do Rust. Well, yeah, and actually the thing that makes me mad about Node is not JavaScript. It's just frickin' asynchronous stuff that makes me really angry, and promises, and the fact that they're just hard to debug for complex things that we really want to do. Just simple stuff, yeah, that works great. Hello world works great. Okay, don't get me started. Don't get me started. We only have 18 minutes left. I don't want to get my blood pressure up getting mad about promises in Java. Okay, here we go. Okay. I don't know how to say your name. Question: what are the perspectives of programming? Is it possible that AI will wipe software development as a profession soon? You're going to have to come back next time, because I got all this stuff about the history of computing with Hidden Figures and the Women of NASA Lego set, and I'll bring it back. Whoa! I'll bring it back, and like Margaret Hamilton. We don't have time to go into all that, but that's okay. That gives me something to talk about next time. When I first came into programming, which was in 1976, 1977, people stated that it was a short period away in 1977. Computers were getting so smart at such a rapid pace that soon your programs would be written for you. Soon the programs would be written for you. There were world-class experts in 1977, 78 that were convinced that computers were going to be sentient by 1979, 80. So, I've seen this crap. This crap springs eternal. The notion that AI is going to figure out how to do what we do is just an eternal thing that faux experts are going to say over and over and over again so they get attention. And they were wrong in the 70s, they were wrong in the 80s, they're wrong in the 90s, they're wrong 2000s, 2010s, and now they're wrong again in 2020. Now, artificial intelligence has made great progress. Auto-translation of languages wouldn't have been possible without artificial intelligence. A lot of work was done. It turns out that artificial intelligence works best when there are underlying constraints that limit the degrees of freedom of a problem space. And so language translation seems difficult because our brains are not good at it. But it's got a lot of patterns, and it's got a lot of data to be trained on. And so, like an automatic captioning is another good example of things that there's just so much data, and the algorithms themselves can get better with time. And you can use many different kind of algorithms, and then those algorithms can sort of themselves evolve. Do you use do you use genetic algorithms? Do you use statistics, this kind of statistics? And so these narrow problems tend to get cracked pretty well by artificial intelligence. And by the time we start using them, people like me go, artificial intelligence has never done anything great. But others will say, like, well, what about automatic translation? And I have to say, yeah, you're right. That's not very exciting, and it's not writing programs. Will they drive cars? Probably. But constraints will have to change. The one thing you don't want is a bunch of self-driving cars on a road and just a few really rude non-self-driving cars, right? Because you'll be able to just drive a self-driving car off the road by a bad lane change, right? And so, there's all these other things. Now, if all the cars were self-driving and they had a lot of communications, then maybe that has a chance. So just to say, like, oh, artificial intelligence is just uniformly going to get better, the answer is no. artificial intelligence tends to kind of get better, and then it narrows, and then it gets this little tiny thing, and it gets really good at that. But it's hardly at that point artificial intelligence. It's just a technique, right? And so machine learning, what does that solve? It solves kind of anything, but then over time you figure out the thing it really tends to solve. Programming. No, it won't do programming. It really won't. The closest thing that, to me, where artificial intelligence can do programming is SQL, structured query language. If you say select from table, join table on this, make a bunch of tables, make a bunch of indexes, and then you do a big long join, that code for you, that join, is being written for you. You have expressed what you want to happen, and billions of dollars of some of the smartest programmers and smartest researchers in the world have made Postgres sentient. When it comes to this little narrow problem of there's a 50 petabytes of data out there, and I want to know what the last 3 grades are that you got in this class. And you don't have to tell it how to do that. And so in that small domain, Postgres borders on sentient. Now, if you're taking PG free, Postgres for everybody, you will notice that you can say, explain query. So you can tell it to, hey, sentient creature, sentient Postgres creature, explain why you're so smart. So you type your thing and say, instead of running the query, you say, explain the query. And Postgres will share with you its intuition. And you're like, oh, yeah, I can see how that worked. Okay, great. And so, really good AI that borders on sentient also can tell you what it's doing. And the same, you see this like when people are driving Teslas or letting their Teslas self-drive, they'll put a camera in the back of the car, and you can watch on the display. And you can watch on the display, and you can see what it's thinking of and what it's trying to do and what confuses it and what works. And so you see all these things where, a Tesla was driving down the road and there was some construction making you change lanes, but the Tesla didn't see it. But then you can watch the video and you can see what the Tesla algorithm is thinking inside of it, and you look at it and go like, yep, that algorithm needs to get a little better, because the fact that these cones were too far apart was confusing the algorithm. If those cones were closer together or if it was a solid thing, it would have figured that out. Oh, wait a sec, the sun is at the wrong angle, and that's what's confusing the Tesla, right? And so artificial intelligence can be quite amazing, but at some level, you can ask it questions, right? It can reveal to you the source of anything that seems like intuition is really more algorithm than intuition. And the best AI is that AI that can reveal to us. And there are generalized techniques like genetic algorithms and machine learning that are very general, but you still got to give them a space in which to work. And so you can't just say, solve this problem. And so programming, unfortunately, just keeps moving. So in the 1970s, we didn't have computer networks. We had to write a lot of programs. Just about every program you ever write now has something to do with computer networks. How did the artificial intelligence figure out the day that networks were invented how to do it? And here's the thing. Software development that seems sentient tends to use libraries. So it's like, I can do this real easy thing, and the library does all the hard work for me, like Python and Beautiful Soup. Well, the problem is that you can't. The big problem is really hard, and what's the interesting engineering is, how do you change Beautiful Soup, and you write a program, and then this program has a limitation, so you add something to Beautiful Soup, and then your program grows, and then your program shrinks, and then Beautiful Soup grows. And this whole thing of like, where do you put functionality? Do you put it in your program or you put it in your library? Over time, that's really an engineering process. It's not intelligent. There's no intelligence. It's just a repetitive optimization process. And it's not an optimization process that's as simple as like, how many lines of code? Let's move them over. No, because when you move it, you got to change it. You got to generalize it. And so, it's just so hard to build modular software. And object-oriented design, which I talked about earlier, like, how could a computer begin to contemplate what the right way to decompose a problem really is? If the problem is so simple, like a database query, yes, intelligence can grow that saves us time, but not intelligence that can grow, that can replace us. So there we go. So we got 9 minutes. Yeah, so Victor, I would really recommend that Postgres is a good thing to do. So Soma, I think contributing to open source projects is pretty what a thing to do. It's hard though. It's hard to get into them. And that's actually one of my research areas, is to figure out how to get people into programming. Do you think the ease of programming is kind of removing the fun of programming? Because most of the things we do are the same nowadays, and there's no need to build things from scratch. Milad, I completely disagree with that. I find programming more fun when I'm more productive. If I could, because to me programming is, there's libraries and hardware and disk drives and stuff over here, and then there's users that want things done, and I'm the person who's kind of marshaling all these resources and making them meaningful for users. And the more users I can affect, because my programming is more efficient, because I build like good libraries. I mean, you see I write Python for everybody, Django for everybody, web applications for everybody, PG free. I'm using the same software to build all those things, and I worked really hard on that software. And so now it's really easy for me to make a new one, and I'm trying to make a new one for internet history, because I've got some interest in internet history, to make a internethistory.com kind of a website. And so for me, the easier it gets, the more users I can affect. And so the easier programming gets is not boring. It's quite the opposite. If I'm in a situation where programming has gotten easy for me and then somehow that's taken away, and it does happen this way, where it gets harder again. Yeah, it's challenging and it keeps me busy, but I get really mad. I get really mad because, look, I don't have time for this. Everything I do is a part-time activity. I don't work full-time. The only main job I have is being a professor, but everything else, software development, etc., is all my part-time thing. And so I maybe I want to go take a walk instead of coding all the time. And so the easier it gets, the more things I can do. Rob, where to find the best open source projects to contribute to? That I don't have the answer to. I'm going to work on making my open source projects easier to contribute to. So, yeah. Okay, let's see what else we got. I'm going to go visit your beautiful island. Charmin 1, lol, like we'd never need anything better than a 486 computer. That 486 was a fine computer. And the thing about it is, with Linux is such an efficient operating system that we don't need as much hardware as we think. And so that's one of the things, like if you look at the new Apple M1 processor, and you look at its thermal efficiency, its the battery life in those computers, things like efficient operating systems that are written in C make it possible for us to waste less of our precious energy and natural resources heating things up with microprocessors that are overbuilt. And so I think often of I can visualize the my first 486 computer, and that was a capable computer. We've gone a long way to slow computers down so they need more processing, and the applications. I wasn't doing video editing on a 486, and so I'm looking forward to my new MacBook. I actually have a new MacBook M1. It's the first new Mac. This Mac that you're seeing. When I come to Sri Lanka, I hope to see you in Sri Lanka. I do want to do more traveling. But if I look at this computer is a 2012, about this Mac. Oh, come back, out this Mac. This is a 2013 MacBook, and I literally have never purchased for myself a new Mac. I only buy used Macs because I didn't like them. They finally fixed in a new Mac the things I didn't like about the new Macs. I liked their power. I liked their heat. I didn't like their plugs. I wanted a plug so I could plug in like HDMI. And they finally got it. So I ordered it, and I received the box, but I'm afraid to open it. I have a brand new Mac sitting in my office in a box because I just love this Macintosh so much because it's like old legacy Macintosh. And it does everything I want, and the keys are worn off on it because my thumbs have hit them so many times because it's almost, 2013 to 2000. It's like 9 years old, 8 years old, and I just have been banging on this thing, and it's been a good friend of mine for a long time. I took it all over the world, like you can see. If you look here, you can see like my PyCon India from 2018. You know, you see all these stickers mean so much to me. I don't even know what I'm going to do when I get a new Macintosh, and like I'm going to lose all my stickers. These stickers are my memory for the past 5-6 years. 2018, and well, that was one of my later stickers, and so I don't even know. I haven't opened it yet. I've had it for 4 days, and I'm afraid to open it. I'm afraid that, like, I don't know. I'm just afraid. Maybe I will open it because I know it's going to take me a long time to figure it out because I got to make sure that Java works on it and Docker works on it and all those other things. So we just have a few more minutes, right? And I'll tell you, I'm glad we had conversation and we had questions, but I'm going to tell you a little bit about what I'm going to talk about next time, if we have time. And so I brought in here my, I brought one of my, I'm not a Lego person. I have lots of friends who are Lego people. And so this is the only Lego kit I've got. And so this is the Women of NASA. And so we have 3 women in NASA. Some are astronauts, and some are like astronomers, and then there's 2 programmers in here. And so this one programmer is Margaret Hamilton. And so she's famous for, so I got the Wikipedia, so you can go read up on Margaret Hamilton for next time. So here's the Wikipedia page for Margaret Hamilton, and she's famous for this thing of like a bunch of printouts that are this tall, and she wrote a bunch of Fortran code. And those of you who have seen my class, I talk about Fortran a lot. It was not my first language; it was my second language, and and then of course there is the movie that I was using as an example, Hidden Figures movie, which maybe you should watch before next month so we can talk about it. I highly recommend it. And it talks about 3 African-American women who did programming in the early days of NASA. And it's fun, but I think there's more to this. And that's what I'm going to talk about. We think of like women or minorities as like, it's great to have women and minorities in technology, and we work to increase it. What I'm going to talk about next week is the fact that in the 60s and 70s, they were in our field. And so where did they go? Asking the question of where did they go, not so much, wow, this is really cool, which it is cool, but asking what happened. Because when programming started, women were just naturally part of it. Like Margaret Hamilton was not an anomaly. It wasn't like Margaret Hamilton was someone that they specially recruited so they could have a female. It's just women were everywhere. They just were. And so I'm going to take the perspective next time and talk. Let me see if I can bring it up. I'm going to talk about this from a very personal perspective. And so on the screen, you see one of my teachers. And her name is Helen Spence. And Helen Spence, in 1970s, probably 76 or 77, she taught me operating systems. And so I am, by the way, I'm old, but I'm not as old as the people in Hidden Figures, because they were adults in the 60s and I was a little baby in the 60s. But by the time I was a young man in the 70s, these people who were the very first generation of programmers, like the Hidden Figures, like Margaret, like Helen, they were just naturally part of the world of programming. When I went to college, the fact that I had a woman faculty member, that wasn't even weird. I didn't think anything of it. No one else thought anything of it. This stuff was normal back then. And so I am going to talk a little bit about an oral history of an oral history next time. I'm going to talk about what I saw happen as I saw a field where women were welcome and common turn into a field where women were not. And I've got some data that I'll share with you next time. And I got some stories that I'll share with you next time. And the conclusion of all that is, and I didn't realize this when I started doing Python for Everybody. The conclusion is, I just realized, because I've talked to a bunch of people about this lately, I've just realized that to some degree, the courses I'm building for you, the way I build these courses, are a throwback to the way I was taught in the 70s. So in the 70s, programming was a thing that you just did. It wasn't a science. It was a thing. Programming, people use terms like software carpentry, right? Programming was a thing people did. Any person. There wasn't like a sense of who it would be. And it turns out, and I will leave this for next time, it turns out that there actually was a moment where it all changed. And not everyone knows about that. And I want to call your attention to some of the information that was the moment where the field of programming became the field of computer science, and leads to why I'm so obsessed, not with eliminating computer science, but with giving you an alternative path to a career that is more of a programming career. And I feel like very lonely in this quest to say programming is itself a skill. Programming is a worthy pursuit from an educational perspective. And programming is not the same as computer science. And so that's that moment, that sort of balance between what is programming and what is computer science, and is programming itself a worthy pursuit, or is computer science the only worthy pursuit? And programming is just like a thing computer scientists know how to do. Or is programming itself and the study of programming a worthy pursuit? And that's why I was asking you what we should name C Programming for Everybody, because it's the beginning, and the Programmer Studio that I talked about, all that is really about this programming as a field versus computer science as a field. And so with that foreshadowing of our next regularly scheduled program here in Studio A at the University of Michigan on Washington Street, I will sign off, and I will see you in a month.